Howdy, it's tubalcain, and the subject of this video is how to make a belt guard for the Logan Ward's Powercraft 10-inch lathe. And I've had this lathe now for several years, and it bothers me that there is no belt guard. And at first I thought that maybe somebody had removed it, but I don't believe there ever was a belt guard. So I'm going to fabricate one out of steel and show you the steps that I go through to do this. In the olden days, when everybody was responsible and men were men, there were no belt guards or any kind of protection. And as a matter of fact, you're going to see some real old lathes that didn't even have guards on the gears. And to me, the gears are more dangerous than the belts. But the belts will take your finger off. And my dad had a friend, Ed White, and he lost the tip of his finger on a lathe, something like this. I was 10 years old, and my dad was standing right there when he took that finger off. And that's how I remember Ed White. So guards are a good thing, even though I rant against OSHA and all of that nanny stuff. But we need a guard on here because I've got my grandkids around here. But here's how I go about it. I took my trammel points, not that you couldn't use a ruler, and I took the center to center measurement here. And believe it or not, neither one of these shafts has center holes, which kind of surprised me because you always see center holes, which would make it even easier, but that's no big deal. Then I took the diameter of the pulleys, and this is a 10-inch pulley, but I'm calling it 12-inch because we want some clearance. Down here we've got 5-inch, or 5-inch, but I'm going to call it 6-inch. And I've already made a pattern and kind of double checked it here to make sure it would fit. That's just an old postal envelope. You can make it out of cardboard. Or matter of fact, you don't even need this. You can just write down your dimensions and go right to the metal if you want. So let's go over to the bench. And I have not decided yet how this guard will be fastened or what kind of brackets I will need, but it probably isn't going to be particularly easy to do. Have you noticed that there are certain words you probably have difficulty spelling, no matter how many times you do it? And guard is is a problem for me. I'm still not sure which one's correct, but I think the bottom one there. But I usually have to do it twice, and one looks better than the other when I write it. So, I digress. Can't get the word out. It's too early in the morning. So it's 9.5 inches between centers. I laid that off, but you don't need a trammel, but I had to use that trammel. I've had it for 20 years and never used it, so that gives me a chance to use it. So there we got our 9.5. And then from that I laid out the two circles. First that one, and I forgot what that other, I was doing a little trial and error, that's why you see two different circles there. Same thing on the other end, but I laid those out with a compass. And you're going to use dividers on the actual steel. And then I cut it out. I went over to the machine and made sure that it's what I wanted. And I did this a couple of weeks ago. Now I'm going to make one for the South Bend lathe later on. It'll be similar, but let's talk about the Logan for today. And there's a lot of Logan lathes out there. A lot of them. And they might be under the Powercraft badge. This little clip of video is an afterthought because something occurred to me here as I was editing the video, so I'm adding this in, but I didn't show the complete layout here, nor did I talk about a line being tangent. Remember, tangent means a straight line that touches an arc or a circle or a curve, and the same way a wheel, let's say a railroad wheel that won't flex, would touch the rail. The rail wheel is tangent to the rail. So taking a straight edge, after we have laid out our two circles, and putting the rule, the straight edge, tangent to the circles like this, I just swing it. I got the point right here on the circle, and I swing that until it's tangent and draw the line. So there is tangent. And of course this didn't need to be drawn at all, but I swung full circles. And same thing over here, if I can. And the reason I'm covering this, there's going to be some people out there that do not understand the terminology, and I know there's people in other countries watching this also. They may have different words or versions of that, or a different word that means the same thing. I don't know, but that's what tangent means, and that's how you make that layout. And it really is very simple. And I'm sorry I missed that the first time around, so I hope you understand that. There's a lot of different ways that you can make a guard, and I even considered making a cast guard, showing you how to make the pattern and then making a casting, aluminum casting, but it takes so very long to make a pattern, and I'm only going to be making one of them, so it's a waste of time, and I really do not have a flask big enough, so I'd have to make a wooden flask to cast that, so that's why I'm going with the steel, but I like to cast things if I can. But this is a 16 gauge steel, and it's just something I scrounged up. You can see there's rust on it, and that was all laid out just like what I showed you on the cardboard. Center to center distances, and then using my dividers, if I can find it here, I laid out the circle. Then I took it to the bandsaw. Now I did want to actually cut this out in that school shop where I had been working temporarily, the original welding shop. And by the way, I'm going to give you a shop tour of that right now. Just a short tour of that nice welding shop, and I'm the one that set that up originally when the building was opened about 10 years ago. Then I worked there part-time for about 6 years. Now they have another teacher in there, but I was temporarily substituting while he was out for a couple of weeks, and I wanted to do that on his laser cutter, but we were locked out of that. The kids knew how to run it, but we were locked out with passwords, and I respect that he didn't want anybody playing around with that machine. But I wanted to cut this out on the I think I said laser, but I meant CNC plasma cutter. But since I didn't have access to that, I went ahead and laid it out on the steel here. And if we had done that with CNC, we wouldn't even need the pattern, or the layout here rather. And I wanted a nice clean cut, so I ended up cutting it on the bandsaw. That's what's left of it, using a fine tooth blade, and then it cut pretty nice. And then I took it to the belt sander and cleaned it up a little bit. So I have a nice edge, no burrs, and it's ready for welding here in a minute. But before, let's go to that video right now with the shop tour, and in that tour I'm also going to show you the break where I made these bends. There's another piece here someplace. So let's cut to that, and then I'll get right back. I'm in the high school welding shop where I taught for many years, and I'm back here temporarily to fill in for the welding teacher who is out on a paternity leave. But let me give you a quick tour of this shop, and you can see it's well equipped with blue Miller welders. Many of the things in here I made myself years ago, all the different benches. And got a row here of arc welders on one side and more Miller MIG welders on this side. Over on this side, we've got a nice Scotchman shear. I bought that several years ago. Well, I guess it's about 10 years old now. Seems like yesterday. Lincoln Power Wave welder. And a Torchmate CNC plasma cutter. I'm unable to use it because there is a password required. Of course, I don't know how to use it anyway. Okay, I hope you liked that shop tour, and that's really quite a nice facility. And vocational education is not dead in our city here. And they have a strong welding program with 6 or 7 classes. As a matter of fact, it was more than I wanted to work. They had a 0-hour class, and that was 6 hours a day that I was in there for a 2-week period. But I showed you the Grizzly brake, and I do not have or access to, and the school does not have, a slip rolls. And I did have one years and years ago. I had a nice diacro roller, and if I would have had that, I would have liked to have made these radii in a roller. But I'm going to do this by a different method, I hope, when I do the South Bend lathe. But what I did here is to make a series of bends that I call press brake type of bends, and these are 1 inch apart. Now that was totally baguesse and bagache, and I did some samples on scrap and finally ended up with the approximate size that I need. And it's not a real good fit here, but I'm going to show you when I start to weld this up how I'm going to force that in there. And I think it'll still have a reasonably nice appearance. Now I of course made that in 2 pieces, and the reason for that is I didn't have material long enough, and it would have been most awkward to do. So I think this is so much better to be done in 2 pieces, with 2 pieces. And this piece I made the bend every 1/2 inch because it's a tighter radius, so you can see the difference. Now this isn't something I have done very often, so this is again experimental, and I call it baguesse and bagache. Now these pieces of steel I also had to cut. Let me grab a piece here. These are drop-offs from a local factory, and it's 14 gauge, and that's how long they were. So I always work around whatever material I can scrounge up. And I slit these down the middle, and you notice that on that lathe that's a double shiv, so I wanted to make it so the guard would cover both pulleys. So I laid this out and cut right down the center so that I got 2 pieces. It's about 2.5 inches is what it is. I did have a boy at school who claimed that he was an expert with the plasma cutter, and he was going to slit these for me, and I had him do a couple, but they were just unusable. They were just horrible, and I threw that stock away. But you know, whenever somebody volunteers that they really know how to do something, you got to question it, because he really was clueless, but he was good-hearted. You know what? I love doing this kind of work. Now this piece doesn't set quite flat, but that'll be taken care of out in the garage. And I have to do the welding outside, and the weather is still real nasty here. It's early in April of 2016. So when I'm done here in a few minutes, I may not get out in the garage for several days, or it could be several weeks, because you know, April is a cruel month in Illinois. But the game plan is to put a tack weld right here, and then clamp it and work it tight so I have very little, if any, gap, and then make tack welds all the way along there as I tighten this. That end being done, I'll start to work on this, and again, you know, I'm a big proponent of having things extra long, so this piece will remain as it is, but this piece, as I start to fit it, will be cut on both sides, and just one weld on each side to hold it together. Nothing hot enough where it's going to warp this. And this also will be worked in, and I've already made up a little jig for this, which I'll show you now, but I'll show you out in the garage also. But that's the way I intend to do it. And you know, I give a lot of thought to this, because I don't do things like this very often, but I get the television on sometime, but I'm not watching TV. I'm thinking, and I think my way through something like this over and over, and I know you guys out there do that too. If you got wheels turning in your head, even when you're in bed. Okay, here's what I came up with. This is a piece of 1/2-inch cast aluminum, and actually it's an old match plate from a factory in town here. Perfectly flat and true. And there's screw holes under there, but that doesn't matter because I took a file and I dressed it. But right here I've clamped a piece of aluminum with a screw that is tapped, drilled and tapped into the plate. And here I got a couple screws that I can use to press against the work. And the work itself will be C-clamped down here, probably with a couple clamps, and then another one over here. And again, what I'm going to do here is tack weld it here, and then these two screws will force it up against this plate. Now the reason I got two screws is because one would probably pivot this as I tighten it. It would pivot. So I got two screws here, and these screws are very close down here to this plate so that they are pretty much pressing, well, not perfectly, but pretty much pressing very close to this plate. And then I will loosen the clamps and I can swing the work around, and I'll be working in different positions along here. And I hope to show you some of those steps when I'm outside with my Lincoln MIG welder. So that's it here at the bench for a while. I'll see you outside tomorrow or the next day or a month from now. To be continued. Thanks for watching. One last thing I wanted to do before I do any welding is put a 2-inch hole in here. I'm going to do that with a hole saw. I'm on the Bridgeport mill now, and it's more convenient to clamp it now with this type of clamp before I have this welded on it. So that's why I'm doing it now. So I've already centered it, and I'm going to drill this with the 2-inch hole saw at the lowest speed, which is 80 RPM, and I forgot what the cutting speed is, but it's probably about 50 surface feet per minute. And you know, you just can't run them slow enough when you're using a hole saw. That's why you see so many hole saws damaged at auctions, used ones. They're just torn up because most drill presses cannot run them slow enough, and it just ruins them instantly. So run these at a slow speed. I like to do it on the Bridgeport because I can hold the work properly without any danger of it grabbing. I have already drilled a 1/4-inch pilot hole in there, and before I did that I scribed a series of concentric rings, which I may or may not need, and I'll talk about that later if they prove to be useful. And it's handy to do that before you lose your center hole for your dividers. And on a Bridgeport in back gears we have to run the motor in reverse, and don't spare the oil. Reverse. I've also lined up the pilot drill with the middle T-slot on the table so I don't drill into the table, and I got a piece of scrap wood underneath. You see, there's no horrible noises or anything like that going on when you run it at a slow speed. Even that slipped a little bit. The belt slipped just a little bit. Well, I take that back. The shank of the drill chuck is slipping in the collet, so I'll stop for a moment and tighten that. That's more like it. Oh, that didn't take much at all, did it? And I'm done. I'll deburr it, and I'm ready to go in the garage. Be sure and use quality hole saws like this Morse. Notice it is still in perfect shape. I've seen men get in a virtual fist fight at auctions over buying a box of badly damaged hole saws, particularly if they come from a plumber's shop where they ran through beams with nails and all that at high speed. It just tears them up. They're useless. And don't buy the cheap non-high-speed steel. Be sure and get Starrett or something like that. Using my Noga deburrer, I'll deburr real well on both sides so I don't cut myself.